Welcome back to B-Spice. In this session, we'll discuss about a new topic again, fiber optics, fiber optic cable, outline. Okay, so outline in the sense, we'll focus on what is single mode fiber and what is multi-mode fiber. In fact, this was requested by one of our viewers and he has commented. That's why I'm uploading it. Okay, so let's go into the details. Of course, as I said earlier, we'll focus on single mode fiber and multi-mode fiber in this session. Of course, many more are going to come in the next session, wherein we'll focus on the differences between single mode and multi-mode in detail. And of course, we will also have a question and answer session for this fiber optic cable. Right. So single mode, this is how the single mode looks like. As you can see here, this is a single mode fiber and this the core you see 9 micrometer, okay, and cladding is about 125 micrometer. Anyway, now see, single mode fiber, we call it as SMF, right? It's a fiber that allows only one mode of light to transmit, just one mode of light to transmit. So typically, this fiber includes a small light carrying core about 9 micrometer diameter. So that is the, spec here, technical spec. So these feature a small model dispersion for vast and distant signal transmission. Just note down this vast actually. So yeah, these feature a small model dispersion for vast distance signal transmission. In contrast with multi-mode fiber, which I'm going to talk in the next slide, single mode enables the concentration of light to travel quicker and further. That's a point. Just note down. Travel quicker and further, which is crucial for high-speed network over a long distance. So that is the beauty. Okay. Just if you want to have a quicker travel and for long distance, usually and for high speed network, okay, so this holds the key single mode. Okay, so that's about the single mode fiber. Okay, now let us go into the multi-mode. As you can see here, the multi-mode and cladding is same 125 micrometer, and this differs. I'll explain this also here, the diameter. Okay, so unlike single mode, the multi-mode fiber, we call it as MMF, allows multiple light, right, to transmit and pass through. As simple as that. So typically, this fiber includes a large light carrying core, larger. It's not a single, it's a larger light carrying core about 50 micrometer or 62.5 micrometer diameter. Whereas in single mode, it's a 9, it's a small. So here it's a large light carrying core. That's the difference. So that makes the manufacturing easier, of course, and offers a low cost ratio on the same length. That's on the advantage part. However, when we talk about the model dispersion limit, the most significant length of transmission connection. So the model dispersion limits the most significant length of transmission connection. So from this, you can interpret that it is not suitable for what? Longer distance. So that is the point, right, friends? Good to go. So this is all about the multi-mode actually. So these fibers are mainly for short distance transmission of signals. So that's it. Okay. Yeah, this is about the simple notes about the multi-mode. Now I'll go dive deep into the types of multi-mode. Multi-mode have a lot of types actually, 5 types in fact. OM1. So OM is nothing but optic mode, optic multi-mode. That's why we call it as OM, optic multi-mode. Okay. So this OM one, actually the diameter is 62.5 micrometer and an orange jacket. Orange jacket means the cover. Okay. So I will explain that in the differences when we talk about the multi-mode as a single mode. I'll talk about the color code, color jacket, everything in detail. Okay. Just imagine now diameter is 62.5 micrometer and an orange jacket. That will be in orange color. So with a 200-500 megahertz kilometer overfill launch OFL bandwidth at 850 by 1300 nanometer. Okay. So with 200 by 500 megahertz kilometer overfill launch bandwidth is about 850,300 nanometer. This I'm talking about the specification. So suitable for 100 megabit and 1G Ethernet applications. Okay, this is about the OM1. So when we talk about OM2, this is about the diameter of 50 micrometer and of course orange jacket. And with 200 by 500 megahertz overfill launch bandwidth at 850 by 1300. Okay, it's almost same actually. So there is no much difference, but only difference is this the diameter. Okay, and here you may ask what is bandwidth. So bandwidth is nothing but the amount of data transmitted, friends. The amount of data transmitted for the fiber optic. Okay, so OM1, OM2 clear, right? Okay, I think some more is there. Yeah, suitable for 100 megabit, 1G. And here only one difference is addition to the 100 megabit and 1G Ethernet, we have a 10G also. That is the only difference here. OM2. Okay, I think we are good to go. Okay, yes. Yes, so that's it. Then we go to OM3. Yes. So OM3, this is a laser optimized multimode fiber, supports 2000 megahertz per kilometer. 2000 megahertz actually. That is the beauty of this. And effective model bandwidth actually. And with a diameter of 50 micrometer and have an aqua jacket. That is the construction features. OM3. And when you talk about OM4, this further is optimized actually. It supports 4700 megahertz per kilometer. Okay. EMB bandwidth actually. Okay. So that is about, and of course is suitable for 10 Gbps, 40 Gbps and 100 Gbps transmissions. Higher rates. Okay. Higher speed. Okay. So this is about the OM4. Then when we talk about OM5, it is known as WMMF, meaning wide band multi-mode fiber. So it uses two fibers to transfer data at speed ranging from 40 GB, 100 GB and 400 GB. So that is the beauty. So when you go from OM 1, 2, 3, 4, 5, as it number goes high, you have the speed, varying speed. Okay. So that's about this all for this fiber optics outline, friends. Okay. Thanks for your support. Keep supporting and keep watching. And don't forget to subscribe. And if possible, you can share with your friends also. Okay, let's go into the single mode versus multi-mode in the next session. Thank you. See you.